Australia's gold mining industry just hit a staggering milestone. Over 320 tons of gold produced annually, worth more than $27 billion. But here's what most people don't realize. Not all goldfields are created equal. Some regions in Australia are producing wealth on a scale that dwarfs entire countries. The Kalgoorlie Boulder region alone has extracted more gold than most nations will ever see. And the story behind these mega-rich deposits reveals secrets about where the next big discoveries might happen. Gold fever isn't just history in Australia, it's happening right now. While everyone focuses on lithium and iron ore, the yellow metal continues to drive some of the most profitable mining operations on the planet. From the legendary super pit to hidden high-grade zones in Queensland, Australia's goldfields are experiencing a modern renaissance. Production records are being shattered, exploration budgets are exploding, and geologists are making discoveries that redefine everything we thought we knew about where gold hides. Let's start with the undisputed champion, Western Australia's Eastern Goldfields. This isn't just Australia's richest gold province, it's one of the most prolific gold-producing regions in human history. The Kalgoorlie Boulder Mining District has produced over 60 million ounces of gold since the 1890s gold rush, and incredibly, it's still delivering massive production today. The Super Pit, officially known as the Fimiston Open Pit, dominates the skyline of Kalgoorlie. This colossal excavation stretches 3.5 kilometers long, 1.5 kilometers wide, and plunges more than 600 meters deep. Every year, the Super Pit produces approximately 700,000 ounces of gold, making it one of Australia's single largest gold producers. But here's what makes this operation truly extraordinary. After more than 30 years of continuous mining, the ore body shows no signs of depletion. Northern Star Resources and Newmont Corporation, two absolute giants of the industry, jointly operate this behemoth through Kalgoorlie Consolidated Gold Mines, or KCGM. The current life of mine extends beyond 2035, and with ongoing exploration revealing deeper high-grade zones, that timeline keeps extending. The geological system feeding the super pit is so vast that geologists estimate billions of dollars worth of gold still remains locked in the rock. But the Eastern Goldfields isn't just about one massive pit. The entire Kalgoorlie-Coolgardie corridor is absolutely saturated with world-class operations. Northern Star Resources operates the Canona Bell mine, which consistently delivers over 200,000 ounces annually from underground operations. The ore grades here can reach 8 to 12 grams per ton in high-grade zones. That's exceptional quality that makes mining incredibly profitable even when gold prices soften. Then there's the St. Ives gold mining system, another Northern Star powerhouse. This operation isn't a single mine, it's an integrated complex of 5 underground mines feeding a central processing facility. The Neptune, Leviathan, Hamlet, Invincible, and Neptune South operations work in harmony, producing over 350,000 ounces of gold each year. The operational efficiency here is staggering, with all-in sustaining costs kept below 1,400 Australian dollars per ounce, ensuring fat profit margins. What makes the Eastern Goldfields so phenomenally rich? The geology tells an incredible story. These deposits formed approximately 2.7 billion years ago during intense tectonic activity. Gold-bearing fluids surged through crustal fractures, depositing gold along massive shear zones and fault systems. The Boulder-Lefroy Fault System, one of the most significant geological structures in Western Australia, acts like a gold highway, channeling mineralization across hundreds of kilometers. The greenstone belts in this region contain volcanic and sedimentary rocks that provided perfect chemical conditions for gold deposition. When you combine extensional tectonics, the right rock chemistry, circulating hydrothermal fluids, and favorable pressure-temperature conditions, you get world-class gold systems. Geologists studying these formations have identified similar signature patterns in other parts of Australia, leading to major discoveries. Moving north along the Western Australian coast, we encounter another gold powerhouse, the Murchison region. This area has historically been overshadowed by Kalgoorlie, but recent years have witnessed a spectacular revival. West Gold Resources has systematically consolidated operations here, creating an integrated mining platform that's transforming the economics of gold production. The Q operations, Tuckabianna, Big Bell, and Meekatharra mining centers form an interconnected network producing over 200,000 ounces annually. But here's the genius of West Gold's strategy. By centralizing processing and sharing infrastructure, they've reduced costs dramatically while extracting gold from deposits that would be uneconomic as standalone projects. This model is revolutionizing how mid-tier deposits get developed. Ramelius Resources have made the Murchison their hunting ground too, with the Mount Magnet operations delivering consistent production. The underground operations here access high-grade lodes that can exceed 10 grams per ton, while open pit mining handles the broader lower-grade zones. The blending strategy optimizes mill feed, maintaining steady cash flow regardless of short-term gold price fluctuations. Now, let's shift our attention east to Victoria, the Victorian Goldfields. This region produced some of the largest gold nuggets ever discovered, including the famous Welcome Stranger nugget, 72 kilograms of nearly pure gold found in 1869. While the alluvial rushes of the 1850s have long since ended, modern mining is proving that Victoria's gold story is far from over. The Fosterville gold mine near Bendigo has become a global sensation. Kirkland Lake Gold, now merged into Agnico Eagle Mines, transformed Fosterville into one of the world's highest-grade, lowest-cost gold mines. We're talking ore grades that routinely exceed 20 grams per ton, with high-grade zones reaching 50, 70, even 100 grams per ton. That's bonanza-grade material. The Swan Zone at Fosterville revealed itself as an absolute monster. Deep drilling intersected incredibly rich gold mineralization in narrow, high-grade quartz veins. Mining these zones requires precision. It's selective underground extraction using sophisticated techniques, but the economics, they're phenomenal. All-in sustaining costs at Fosterville have been reported as low as $400 to $500 per ounce during peak production years. When gold trades above $2,000 per ounce, the profit margins are absolutely mind-blowing. What makes Fosterville special is the structural control on mineralization. The deposit sits along a major fault intersection where multiple geological events created pathways for gold-rich fluids. The Fosterville fault system acted as a superhighway for mineralizing fluids during multiple tectonic episodes. Geologists have identified that the gold deposition occurred at depths of 10 to 15 kilometers under immense pressure and temperature, creating the spectacular grades observed today. But Fosterville isn't Victoria's only success story. The Starwell gold mine, operated by Starwell Gold Mines, has been producing continuously since 1981. Recent exploration has extended mine life well into the 2030s by discovering deeper extensions of known ore bodies. The combination of underground and processing expertise built over decades means Victoria knows how to extract gold efficiently from hard rock deposits. Queensland enters the conversation with some truly spectacular gold districts. The Charters Towers region, northeast of Townsville, has historically produced over 6 million ounces of gold. While many historic operations closed decades ago, modern explorers are using advanced geophysical techniques and geochemical analysis to identify new targets in this richly endowed region. The Pajingo mine, operated by Evolution Mining until its closure, demonstrated that high-grade gold systems still exist in Queensland. Underground mining accessed veins with grades exceeding 10 grams per ton, proving that with the right exploration techniques, Queensland's gold potential remains largely untapped. But the real Queensland gold story is happening at the massive Cracow gold mine and the emerging Pajingo district redevelopment projects. Companies like Navarre Minerals and others are systematically exploring the Chillagoe-Mungana district and the Hodgkinson province, where historic mines produced phenomenally rich ore. Modern technology allows reprocessing of old tailings while exploring for extensions of known systems. The Red Dome mine near Chillagoe produced over 1.2 million ounces during its operational life, with ore grades averaging 5 to 8 grams per ton. The geological system, epithermal gold associated with volcanic activity, creates narrow, high-grade veins that require skilled mining but deliver exceptional returns. The hunt for similar deposits drives exploration budgets across northern Queensland. Moving to New South Wales, we find the historic Cobar Basin. This region isn't primarily known for gold. It's a massive polymetallic province producing copper, lead, zinc, and silver. But many of these deposits carry significant gold credits. The CSA mine, Endeavour mine, and Peak mines have all recovered substantial gold as a byproduct, contributing to the region's overall value. The Macquarie Arc in central NSW hosts several developing gold projects. The McPhillamys Gold Project, the Boda Prospect, and several others target porphyry and epithermal gold systems. While not yet in production at the same scale as Western Australia, these projects represent the next generation of NSW gold mining. What about South Australia? The Gawler Craton is emerging as a world-class gold frontier. Aussie Minerals' Karapatna copper-gold operation demonstrates the province's potential. Gold is recovered as a byproduct of copper mining, but the volumes are substantial. The Woomera Prohibited Area hosts numerous exploration targets where early-stage drilling has intersected significant gold mineralization. The Challenger gold mine, operated by Barton Gold, has produced over 1 million ounces since operations began in 2002. Located deep in the South Australian outback, Challenger accesses underground ore with grades around 5 grams per ton. The operation demonstrates that even in remote, logistically challenging locations, high-grade gold deposits can be mined profitably. Northern Territory's gold story centers on the Tanami Desert and Pine Creek region. Newmont's Tanami operations have produced over 7 million ounces of gold since 1986. The Cali underground mine and Granite's processing facilities handle ore from multiple underground sources, maintaining annual production above 500,000 ounces. The Tanami is a major Australian gold province that doesn't get nearly enough attention. The geology of the Tanami mirrors other Archean greenstone belts, ancient volcanic sequences cut by gold-bearing shear zones. The Dead Bullock Soak discovery by Northern Star Resources has confirmed that significant gold potential remains unexplored across this vast desert region. Deep drilling is revealing that mineralization extends to depths of 1,000 meters or more, opening up decades of future mining. Tasmania contributes to Australia's gold production through the Henty gold mine and the Beaconsfield operations. While smaller than mainland deposits, these operations prove that Tasmania's mineral potential extends beyond its famous base metal deposits. The Henty underground mine has navigated challenging ground conditions to extract ore from narrow, high-grade quartz veins. So what defines Australia's richest goldfields? Several critical factors emerge. First, geology is paramount. The richest deposits occur in Archean greenstone belts, ancient volcanic sequences that underwent the right combination of tectonic stress, hydrothermal fluid flow, and chemical conditions. The Boulder-Lefroy Fault, the Fosterville Fault System, the Tanami Fault, these aren't just geological features, they're treasure maps showing where gold concentrated. Second, structural controls matter enormously. Gold doesn't distribute randomly. It concentrates along fault zones, shear systems, and fold hinges, where fractures allowed mineralizing fluids to flow. The Boulder-Lefroy Fault, the Fosterville Fault System, the Tanami Fault, these aren't just geological features, they're treasure maps showing where gold concentrated. Third, scale separates good deposits from world-class giants. The superpit continues producing because the mineralized system is massive, hundreds of meters thick and extending over kilometers. Fosterville achieves incredible grades, but the system is smaller, requiring precision mining. Both models work, but they demand different operational approaches. Fourth, grade versus tonnage creates strategic choices. High-grade deposits like Fosterville can be incredibly profitable even at small scale. 300,000 ounces annually from ultra-rich ore generates huge cash flows. Large tonnage, lower-grade operations like the superpit require massive infrastructure but deliver production consistency and long mine lives. The economics of gold mining in Australia are fascinating. All-in sustaining costs vary dramatically depending on the operation. Ultra-high-grade underground mines might achieve costs below 1,000 Australian dollars per ounce, while large open pit operations typically run $1,400 to $1,800 per ounce. When gold prices exceed $2,500 per ounce, these operations are printing money. But costs aren't static. Labor represents approximately 40 to 50% of operating expenses at most Australian gold mines. Energy costs, diesel fuel for mobile equipment, reagent costs for processing, and maintenance expenses all fluctuate with commodity markets and inflation. Operators constantly optimize to maintain competitiveness. Where are the next big gold discoveries likely to occur? Exploration geologists focus on several key areas. Extensions of known deposits remain the most reliable targets. At Fosterville, drilling continues to intersect high-grade gold at depth, suggesting the mineralized system extends far deeper than currently mined. Similarly, the superpit's depth extensions represent massive untapped potential. Greenfields exploration targets the concealed terrains, geologically prospective rocks buried under younger sedimentary cover. Advances in geophysical surveying, particularly airborne electromagnetics and gravity gradiometry, allow explorers to see through the cover and identify structures that might host gold. Western Australia's eastern Yilgarn Craton contains vast areas of covered greenstone that remain largely unexplored. Geochemical techniques have revolutionized exploration. Ultra-fine soil sampling, vegetation sampling, and groundwater analysis can detect gold anomalies even when mineralization sits hundreds of meters underground. Companies are reprocessing historic geochemical datasets using modern statistical techniques, identifying patterns that weren't recognizable with older analytical methods. The role of technology in finding and mining gold has exploded in recent years. Automated drilling systems allow 24-hour exploration programs with minimal crew. Drill rigs equipped with autonomous controls can execute pre-programmed patterns, collecting geological data around the clock. The speed of exploration has increased dramatically. Underground mining technology is transforming how gold gets extracted. Automated loaders, tele-remote development systems, and autonomous haulage allow mining in conditions that would be dangerous or impossible for human operators. At depth, temperatures can exceed 50 degrees Celsius. Automation allows extraction while minimizing human exposure to extreme conditions. Processing technology continues advancing too. Gravity concentration recovers coarse gold before it enters the milling circuit, improving overall recovery weights. Intensive leaching reactors maximize gold dissolution from fine-grained ore. Flotation circuits recover gold locked in sulfide minerals that wouldn't respond to conventional cyanide leaching. Every fraction of a % improvement in recovery represents millions of dollars at large operations. Environmental stewardship has become central to gold mining. Modern operations implement comprehensive water management systems, rehabilitate mined land progressively, and minimize environmental footprints. The days of uncontrolled cyanide use and abandoned tailings dams are ending. Regulators and communities demand better, and companies are delivering. Tailings management represents one of the industry's biggest challenges and opportunities. Dry stack tailings, paste fill systems, and filtered tailings eliminate the need for large water storage dams while allowing safer long-term storage. Some operations are even reprocessing historic tailings dumps, extracting gold that older technology couldn't recover, while simultaneously remediating legacy environmental issues. Water usage in gold processing has declined dramatically. Closed-loop water circuits recycle process water, dramatically reducing freshwater consumption. In arid regions like the superpit, water management isn't just environmental responsibility, it's operational necessity. Every liter of water must be sourced, used efficiently, and managed responsibly. The social license to operate has become as critical as geological prospectivity. Communities near gold mines demand benefits, employment, infrastructure investment, and meaningful consultation. Companies that engage authentically with local stakeholders, respect indigenous heritage, and deliver tangible community benefits maintain their social license. Those that don't face opposition, delays, and potential project failures. Indigenous partnerships are transforming Australian gold mining. Traditional owners are asserting rights over ancestral lands, demanding meaningful participation in mining projects. Forward-thinking companies are moving beyond basic consultation to genuine partnerships, employment programs, cultural heritage management, and revenue-sharing arrangements that provide lasting benefits to Indigenous communities. The workforce dynamics in Australia's gold mining sector reveal interesting trends. Remote fly-in, fly-out operations dominate in Western Australia and the Northern Territory. Workers spend weeks on site, then weeks at home, creating unique lifestyle challenges and opportunities. Salaries are competitive. Underground miners, processing operators, and geologists earn substantial incomes, particularly in remote locations. But the industry faces workforce challenges. An aging demographic means experienced miners and metallurgists are retiring faster than new professionals enter the sector. Universities report declining enrollment in mining engineering and geology programs. Companies are responding with apprenticeship programs, partnerships with technical colleges, and initiatives to attract young talent into the industry. Automation partially addresses workforce gaps, but creates new skill requirements. Operating autonomous systems requires different expertise than traditional mining. The industry needs software engineers, data analysts, and automation specialists, roles that didn't exist in mining decades ago. The transformation from labor-intensive extraction to technology-enabled mining is fundamentally changing who works in gold mines. What about exploration investment? The numbers are staggering. Western Australia alone attracts over $1 billion Australian dollars in gold exploration spending annually. Junior exploration companies, backed by sophisticated investors, systematically test geological concepts across the continent. The success rate is low, maybe one discovery in 100 prospects, but the potential rewards drive relentless exploration. The capital markets supporting gold exploration are fascinating. Junior explorers list on the Australian Securities Exchange, raising capital through share placements and rights issues. Retail investors, institutional funds, and strategic industry players all participate. When significant drill results hit, share prices can multiply overnight. But failures are common. Most exploration projects never become mines. Major producers also invest heavily in exploration. Northern Star Resources, Evolution Mining, Newmont, and others allocate hundreds of millions of dollars annually to finding the next generation of deposits. These companies have advantages. They can test deep targets that juniors can't afford. They have processing facilities to treat bulk samples for metallurgical testing, and they possess decades of geological understanding. The relationship between juniors and majors creates an ecosystem. Juniors make initial discoveries, proving up resources through drilling. If a project shows promise, majors might acquire the junior company, bringing financial muscle and operational expertise to develop the mine. This cycle has driven Australian gold mining for decades. Technology transfer from other industries is accelerating gold discovery. Machine learning algorithms analyze vast geochemical datasets, identifying subtle patterns humans might miss. Satellite imagery detects vegetation stress caused by mineralization leaking into soils. Three-dimensional geological modeling allows geologists to visualize complex ore body geometries and plan drilling with unprecedented precision. Climate change is impacting gold mining operations. Extreme weather events, shifting rainfall patterns, and increasing temperatures create operational challenges. Open-pit mines in Western Australia are designing for more intense cyclones. Underground operations are investing in cooling systems as geothermal gradients push rock temperatures higher. The industry is adapting, but climate change adds complexity and cost. Energy costs and carbon emissions are forcing transformation. Gold processing is energy-intensive. Milling, crushing, and pumping require enormous amounts of electricity. Operations are investigating renewable energy solutions. Solar farms, wind installations, and battery storage systems are being deployed at remote mine sites, reducing diesel consumption and carbon footprints. The Gruyere gold mine in Western Australia demonstrates this transition. The operation installed a massive hybrid power system, combining solar, battery storage, and gas generation, reducing diesel consumption by millions of liters annually. The capital investment was substantial, but operating cost savings and environmental benefits justify the expenditure. Battery metals and gold create interesting synergies. Many gold deposits contain copper, cobalt, or other metals critical for battery production. Processing circuits can be designed to recover multiple commodities, improving overall project economics. The M.T. Morgan's Gold Project in Western Australia is exploring polymetallic potential, recognizing that 21st century mining must be multi-commodity to maximize resource value. Looking at global gold markets, Australia's position is powerful. Australian gold production represents approximately 9% of global output, making Australia the world's second or third largest producer, depending on the year. China leads, but Australian gold is prized for its quality and ethical sourcing. Refineries worldwide trust Australian gold as responsibly produced. Gold exports contribute enormously to Australia's trade balance. Annual gold exports exceed 20 billion Australian dollars, making gold one of Australia's most valuable export commodities. While iron ore and coal generate larger volumes, gold's concentration of value, small physical volume, enormous monetary worth, makes it uniquely important. Where does Australian gold go? The primary markets are refineries in Asia, Europe, and the Middle East. Perth Mint, one of the world's largest gold refiners, processes much of Western Australia's production into bullion bars, coins, and other products for global markets. The chain from mine to market involves rigorous quality control, chain of custody documentation, and compliance with international standards. The future of Australia's gold industry looks extraordinarily promising. Gold prices have shown remarkable resilience, supported by central bank purchases, geopolitical uncertainty, and gold's role as a monetary asset. At 2,500 to 2,700 Australian dollars per ounce, nearly every Australian gold operation is highly profitable. The incentive to find and develop new deposits has never been stronger. technological innovation will unlock deposits previously considered uneconomic. Deeper drilling, more sophisticated processing, and automation are extending the envelope of what's mineable. Deposits that require mining at 1,500 or 2,000 meters depth, once inconceivable, are now feasible with modern technology. The next super pit might be entirely underground, accessing gold systems that older technology couldn't reach. Exploration will continue transforming our understanding of Australian geology. Geoscience Australia and state geological surveys are conducting comprehensive geophysical surveys, creating publicly available datasets that fuel discovery. The Exploring for the Future program is generating new geological interpretations, identifying prospective regions that haven't received adequate exploration attention. Junior explorers will make unexpected discoveries. The beauty of gold exploration is that the next major discovery could come from anywhere. A small company with a clever geological theory, backed by persistent drilling, might stumble onto the next Fosterville. That possibility keeps exploration investment flowing and geologists tramping across the Australian outback. The richest goldfields in Australia share common threads. They occur in geologically ancient terrains, they're controlled by major structures, they've experienced the right combination of heat, pressure and fluid flow, and they're located in jurisdictions with stable governance and mining-friendly regulations. Western Australia dominates because it ticks all these boxes. But geology alone doesn't create successful gold mining. Operational excellence, financial discipline, safety culture, environmental responsibility, and community engagement all determine whether a deposit becomes a profitable mine. Companies that excel across these dimensions create lasting value. Those that cut corners inevitably face consequences. The human dimension of gold mining deserves recognition. Behind production statistics and geological models are thousands of dedicated professionals. Geologists piecing together complex puzzles, engineers designing innovative solutions, miners working in challenging conditions, metallurgists optimizing recovery, environmental scientists ensuring responsible practices, all contribute to the success of Australia's gold industry. Australia's Indigenous peoples have known about gold occurrences for tens of thousands of years. While gold didn't hold the same cultural significance as ochre or other materials, Indigenous knowledge of the land has occasionally guided modern discoveries. Respectful engagement with traditional owners isn't just ethically correct, it's smart business that can unlock geological insights. As we look toward 2030 and beyond, Australia's gold production will likely remain strong. New discoveries at Fosterville depths, super pit extensions, Tanami expansions, and entirely new districts coming online should maintain output above 300 tonnes annually. Australia's position as a global gold powerhouse seems secure. The wild card is exploration success. If a truly giant discovery occurs, a new Golden Mile or another Fosterville-scale system, Australian production could surge dramatically. The geological potential exists, the exploration investment is flowing, the technology is available, the incentive is clear. All the ingredients are present for the next major Australian gold discovery. So where are the big finds happening? Everywhere, geological fundamentals align with modern exploration. The super pit continues expanding, Fosterville is drilling deeper, the Tanami is revealing hidden treasures, Queensland is experiencing a renaissance, South Australia is emerging, the Northern Territory holds vast potential. Australia's richest goldfields aren't just historic curiosities, they're active, evolving, and still delivering world-class discoveries. The Australian gold story is far from over. It's entering a new chapter where technology, geological understanding, and financial support combine to unlock deposits that previous generations couldn't imagine accessing. from the legendary fields of Kalgoorlie to the high-grade wonders of Fosterville, from the desert expanses of the Tanami to the emerging frontiers of South Australia, Australia's gold endowment continues enriching the nation and fascinating the world. The next time you hear about Australian gold production hitting new records, remember, behind those statistics are sophisticated operations extracting metal from rock formed billions of years ago. The intersection of ancient geology and modern technology creates something remarkable, sustainable wealth generation from a finite but still abundant resource. Australia's richest goldfields represent human ingenuity, geological fortune, and relentless determination to discover what lies hidden beneath the surface.